Thanks, everyone. So we're here to unveil where we've got to with DAFNI, and it's my pleasure to do so. It's been a long road to get us to where we are today, and hopefully everyone will be as excited about what we've delivered so far as we are. Ultimately, before we go into exactly where we're at with DAFNI, I think it's useful to think about the history and the precedent of what's got us here. And the mindset that we kind of set out with when we began the project was one of how can we improve decision making? And that's not ultimately one of decision making is wrong, but I think everyone will agree there's an opportunity to better understand the decisions that we do make. And that's at the core of the development and the ideology that's gone into the development of DAFNI. And through that, it's the ability to support industry, support government, and support research through in academia, and bring all of that together to create this cohesive and this complete picture. And how are we going to do that? And that is through the provision of this new platform, which is there to accommodate each of these different areas separately. And when we talk about the ability to advance research, I think it can be a bit of a misnomer. It can mean many different things to many different people. And we've tried to break that down into what it actually means for the DAFNI system, and in turn, the users of that platform. So when we talk about greater scale, that's both the ability to run models at scales which might not have previously been accessible through kind of access to greater kind of compute capacity, but it's also to be able to do that at a greater granularity than we might have been able to do before. So when we've got these kind of really high detail models of city areas, whether that's London, Birmingham, Newcastle, what about if we could scale those up to explore the entire UK? And then that can help us understand the kind of the complexities and the interactions between all of these different areas. And that brings us on to this second section, greater complexity. When we start to think about how research has been kind of predominantly conducted over the last couple of years, and going back even further, it's generally been kind of sectorally specific. So we might explore transport, we might explore energy, and we might explore communications. But it's very uncommon that we'll do that in its entirety. There's some kind of pockets of examples of when we're starting to do this kind of cross-sectoral modeling, but it's not a widely adopted practice. And that's often because of the access to data, the models, making those models accessible and interoperable is an extremely difficult challenge. Our vision ultimately, and we've got a fairly simple example here, but where we might have previously just modeled something like a power station or an electricity network as a finite piece, actually, there's a lot of different components that go into supporting that. And when you start to cascade out, you start getting down to people, and they become kind of that critical part of the puzzle. And you might have something as simple as a fallen tree on a road, and that can have a huge knock-on impact, people not being able to get to work and service the infrastructure that supports that. But actually being able to model this is extremely difficult. And once you start getting onto some of the more kind of social aspects, the healthcare aspects, this becomes even more complicated. But when we have a platform where things are much more open and kind of transparent, it means there's an opportunity to bring these kind of disparate communities together and start to explore these problems in their entirety. And then that kind of brings me on to my last point here, which is greater confidence. This is about researchers having greater confidence in the quality of the research they're conducting. Not because to date research they've been doing has been of poor quality, but it means there's an opportunity for them to do kind of more comprehensive analysis of their results, be able to convey the results in a more comprehensive and consistent fashion, have kind of provenance traceability back to source of where those results have come from and where those decisions are being driven. But then if you turn that on to the decision-making authorities, whether those be regulatory commissions and the like, actually for them to understand the provenance and the evolution of data that they're using in support of their decisions is vital. And we really want to encourage and enable that. And again, DAFNI isn't just something that has been dreamed up by a team of developers. Yes, we've had 15 developers working on this for well over a year now and getting us to this point. But underneath that, we're underpinned by groups across industry, across government, and across academia. And without them, we wouldn't have been able to get to the point we are today, because they allow us to translate the ideas and the practices that we've learned from the technology sector and bring them into this new domain. Prior to coming to this, the majority of our team had no kind of prior knowledge about the approaches to infrastructure and infrastructure research. with the support of the community, we've been able to get to the point we are now. We've had things like case studies driven by academia, and we've got some presentations on those later today. And that's there to help us both validate and inform subsequent requirements as we evolve the platform. And then without industry and the kind of input that we get from them in government, it's difficult to see how this advancement in research actually has an effect. It's great if we can let people do research at greater scales and all these sorts of things, but unless that's got a direct avenue for exploitation by industry and government, it has little effect. So in very simplistic terms, DAFNI consists of 5 key parts. Jim touched on these earlier, but I'm just going to kind of touch on them in slightly more detail. The National Infrastructure Database can be thought of as a library of data. Some of the data sets we will hold, some of them we will provide access to in a similar manner you might get a loan on a book from another library. But we make sure that that data is made available in a standardized and consistent fashion, so you don't have to be a technical expert to access that data in a performant manner and with the kind of confidence in the results that are coming back. We've got modeling service, which Nick is here to go into a lot more detail about. But this is how can we democratize access to models? How can we make sure that just because a model is written in a programming language someone might not be familiar with, we're not stopped from being able to exploit what might be very good quality research and information that's housed within that. We've got a cloud environment. I think you should be asking me a question if this wasn't very similar to every other cloud environment, and as such we have modeled it on the best practices from within industry, whether that's Google, Amazon, and Microsoft, and other scientific cloud research environments. And to try and echo that, we've actually developed DAFNI as a hybrid cloud. This means we have our kind of on-site kind of small investment in the grand scheme of things, but the mechanisms through which to cloud burst out into commercial cloud environments as the system needs to grow with demand. We've got visualization. This for me is one of the key parts of the system, because unless we can find an effective and meaningful way to tell stories through the data that we're actually generating, what is the point in generating all of this information? So although we're only starting to touch on this in the current version of DAFNI, this is somewhere we want to put a lot of effort going forward. And is what you'll see tomorrow if you're joining us, is us start to explore that as a community and start to understand what the different ways and different mechanisms through which we can deliver that. And lastly, on the far right, we've got security. DAFNI will never succeed unless we can provide assurances to those that are providing the data to us that we can look after that in a responsible and technically robust fashion. So we've separated that out to make sure that that functionality is isolated within the system and to make sure that we can have that full level of control. Again, we've modeled this off of industry best practices, and we've engaged with industry experts throughout the course of this to make sure the approach we're taking is effective. We will be continuing to refine this. We're not going to get complacent about what we've got now, but we are taking that very seriously, and we're going to ensure that that is done in a consistent and appropriate manner throughout. So just to give you an idea of how much development has got to where we are, I think the best way to look at DAFNI, if you want a kind of infrastructure analogy, we've only really got the foundation in place now. As we start to go forward, we're going to start to build in those nice kind of features that people kind of really get engaged with and start to get some of that real value. But without that solid foundation, that's of little effect. So you may look at parts of the system today and think, oh, have you thought about doing this? Could we do that with it? And the answer is yes, we may have thought of it. No, in some case, we won't have. Is what we've got now is the ability to start to develop those aspects and really start to get some of those rewarding kind of features to the community. We've got enough there today to start to get people thinking and to seed those ideas as we go forward. So to get us to this point, we've developed already over 50,000 lines of code across the team. And this isn't a huge number, but it's still a kind of fair body of work that's taken to get us to that point. We've done over 700 agile tickets across 32 sprints, and that's actually quite a lot of work. And as we've suffered with similar issues to the rest of industry, recruitment is a challenge in the technology space. But we've still managed to continue to grow and make sure we can provide outputs over the course of this. And this has actually been combined through delivery of over 20 different languages we've had to touch on. And that's an idea of how many different expertise we've had to use within that. And that is delivering over 20 independent services within the system. And that compartmentalization of functionality means the platform is extremely extensible, and then we can grow and refine the system as it evolves. So without going too technical, I wanted to just jump back to basics. And what do we actually mean by DAFNI? And ultimately, it's a combination of data, of workflows, and those are processing flows that Nick will talk to you about models, and that's how we generate the insights that we're interested in, compute and visualization. And if you take anything away from today at the simplest level, that's what's available within DAFNI. But the exciting bit is the fact that this is actually specialized for our sector and specialized for the needs of what we need to demonstrate. So we're actually going to try a live demo. So hopefully it all works. So if we can jump over to the other screen. Okay. So this is DAFNI version 1. This is what you will eventually come to see once we increase the level of openness on DAFNI and start to make it available on a wider basis to the community. And it's what you should be seeing here is a relatively simple user interface, and that's deliberate. If anyone's ever used other cloud provisions through Microsoft or Amazon, there's so many different services on there. Unless you're quite technically experienced with those different products, it's very difficult to know where to start and actually how to carry out a lot of the tasks that you want to do. So although this is basic, we've stripped it back to what's the functionality that our community actually needs to use, and that's what's the value that they want to exploit. And as we find things that aren't there, and there's other services we want to provide, we can grow this catalog over the years and over the development life of DAFNI. And as I said, this echoes what we saw on the previous slide. These are the different functions that are available within DAFNI. And within these, there's some different software and different processes that we can exploit. So if we jump into the data catalog, it's what we've got here. This is the current catalog that's available within DAFNI. This is a set of data sets that are either open source ones that we've curated or have been in support of the case studies and the pilot studies we've been carrying out to date. This is a relatively small offering, and again, that's because it's taken a while to get to the point where the system is sufficiently stable to warrant putting larger scale data sets in. So over the coming months, you'll see this catalog continue to grow and scale up quite significantly. And when you see data sets that aren't there, the idea is the community can kind of indicate to us what might want to be there, and we can help to grow. And the really exciting part is you'll see a button up the top which is add data. We're not going to go into that now, but it actually means as a community you can contribute to this data store. As long as you've got the rights and the ownership to do that, it means we can grow this as a community-driven data archive. And that means that it becomes increasingly useful dependent on how well the engagement is across the community. So we've also got search functionality. So if we were to look for transport, it filters down, or if we wanted to look for HS2, as you can see, there's stuff in there. So if we wanted to click on that one, we've then got a series of additional information fields about that. This is to hopefully give people as good a kind of most comprehensive idea as possible whether that data set is useful to what they're actually doing or not. All too often, if you might find there's a 500 gigabyte data set on there, you go download it and you find it's not what you want. So we're trying to make sure that it's all clear and it's all transparent actually what's within there. So as this continues to develop, we'll look at summarizations of data sets so we can really get solid ideas whether there's actually value in that. On the right-hand side, you've got links to the data files and you can start to download those as well. And it's what we've done is we've kept it very flexible. So we have got the ability to put these data sets into structured databases, basically, and that means we can have that high-performance access to it. But as the system grows, we're not going to be able to support every data format that you can imagine. So we've also got what sits behind this called an object store, which lets us store that data of any format as those files, so people can still access the data and still make it accessible to others throughout that process. And that's what we're seeing here. So if we wanted to then jump over to workspaces, this is, I guess, one of the key parts to our actual research community. These are the collaborative kind of experimentation areas where people and projects can work together on shared problems and start to really kind of progress those forward. So if we were to look at one of these, say we jumped into traffic analysis, within here you've then got a series of virtual machines which are accessible to each of the users or members of that project. You've got services, and this is somewhere where we're going to increasingly apply effort. This is are us as a service provider providing managed services. So you've got things like databases, Jupyter notebooks, which are interactive Python development environments, and we can spin these up and expose them to our community automatically. And that means you're not having to mess around at all with the complexities of trying to install this software, make sure it's accessible, secure, all of these different things. It means all of this is managed for you. You've got the virtual machines, all of these are accessible as well. Currently, they're restricted to access through command line, but we'll be evolving that over time as well to make sure you can access them through graphical user interfaces. But the key thing is here, everything we see, whether it's data or workspaces, you're only seeing what we have permission to see it users. So if somebody published a data set that had some sort of restrictive license on it, other users on the platform wouldn't necessarily even be aware that that existed. It's all controlled and it's all isolated so that we can provide those kind of sufficient assurances to the community. And that's why this is so important. This means people can work together on projects, but with the confidence that their IP, the security, all of these stuffs are insured for them and on their behalf. So I'm going to pass over to Nick today, who works at Tesella, and they've been supporting us with some of the complexities of developing the modeling service, and he's going to talk you through that.
Fantastic. Thank you, Sam. Morning, everyone. Yes, so I've been asked to come along this morning and talk a little bit about the National Infrastructure Modelling Service, which really picks up on the modelling and the workflow concepts within DAFNI itself. But really, the modelling service is there to democratise DAFNI's overall capabilities. We recognise we have a very diverse community within the room today, and that DAFNI targets. You have a range of different skills, interests, and insights into the data. And while today we are focusing very much on the web interface that we provide, which provides the services at the most accessible level. Everything we're showing today has command line interfaces and programmer interfaces as well. So for the more technically focused researchers we have in the room today, you can write your own applications but have DAFNI's capabilities enshrined at their core. The modelling system really encapsulates all of the things that Sam has talked about. We're talking about predominantly here models and workflows, but we also have data and workspaces and access to the cloud environment within the modelling service as well. And that really allows you to have a seamless workflow. You can extract your data from the data store. You can run your modelling and simulation scenarios. You can run custom code to post-process the results from that. You can visualize, and you can ultimately publish your data back into the infrastructure data store. And you do all of that through our workflows, and those allow you to curate processes, provides reusability and traceability as well of what's happened. And it does all of this through intelligent use of computational resource, whether that be through data storage or computation to run your models and simulations through. And really, all of that lowers the barrier to entry to research. You don't have to worry about where your data is going to come from or how you're going to store it. You don't have to worry about procuring expensive IT infrastructure and going through processes there. You haven't got to worry about how you're going to set up your own cloud environment. You use the NICE. It's already there for you. And finally, we enshrine good research practices by default through a series of frameworks that come with the modelling service. That provides provenance and traceability, as has already been touched on a couple of times already, but also then allows for reuse. We can publish our workflows, we can publish our models for the wider community to engage with. So let's start by taking a look at models within the modelling service. So the modelling service within DAFNI supports two kinds of model. We have discrete models, such as the 5G and the non-spatial housing model displayed here. These represent single facets of a more complex system or an isolated concept that can be modelled on its own. We then have multi-component data models as well. And those represent more complex systems, perhaps system of systems models, typically things like NISMOD or the Spencer microsimulation assemblage. We store our models within a catalogue. It's very similar to the concept that Sam introduced for data. We provide basic information at a highest level, and if we can find something we're interested in through the search capability, then we can select something and we can gain more information about it. So we start off with some very basic data, but then ultimately we have much more information, and you can use this to decide if this is an appropriate model for the research activity you want to undertake. All of this descriptive content is moderated when a new model is added to the system and is curated long-term by a stewardship group to make sure that the content remains appropriate and current over the lifetime of the model's existence or indeed DAFNI itself. And all of this is based on something called the National Infrastructure Model Definition. This is a file that gets provided with every model that's submitted into the system. It provides this basic descriptive information, but then also contains information about all of the input variables that a model might take. And we use that within the automated workflow processing systems to make sure the model you're executing is correctly configured and is going to run as we expect it to. And we'll see a bit more on that in a moment. We're hoping that this modelling definition will become a national and international standard. We're already in conversations with the BSI to try and argue why such a standard is important. And for us, that's fairly obvious. It's because everyone who models to this standard will be able to import their models into the DAFNI platform. They will execute, and we have those available to the wider community. And the model we're using is similar to that's recently seen the BIM standards ratified through the BSI. All of our models are covered by the DAFNI Security Service. As Sam has said, security is ingrained throughout DAFNI. And our models at time of submission, the owner is allowed to specify what they want their security settings to be from completely open, so that anyone with access to the DAFNI platform can run their model, right the way through to controlled access to a list of named individuals, to private access for the model owner only. We combine that with the credentials that have been used to log in to dictate which models appear in the list here, and therefore what I as a user am able to execute. So that's the basics of models. If we take a look at workflows now, we can start looking at how models are used in a little more detail. So a workflow is essentially any research activity that consists of multiple steps. And we store them in a standard format, which allows for reusability, so that they can be shared within a community, but also reproducibility, so that they can be rerun over and over again if necessary through something like a sensitivity analysis, or perhaps if results are being scrutinized publicly. Again, we have a catalogue-based metaphor, similar to data and models, so we can see basic information about the workflows we have in the system. And we also, and this is also, again, security monitored in a similar way to models, such that only the workflows that I have particular specific permission to run appear in my list and are available to me. The best way to really describe what happens with workflows is to use an example. So I'm going to pick on the housing demand model, which comes out of the Institute of New Economic Thinking at Oxford University. This is through Adrian Caro, who I believe is here today. This is a typical discrete model within DAFNI. It takes 14 different input variables, and of course each one of those is going to impact the way the model runs and therefore the results it generates. Perhaps we want to understand how one of those variables is going to impact our results, and so we want to run some kind of sensitivity analysis. We might choose to do that through a Monte Carlo simulation. We can then aggregate all the results of those multiple runs, having varied our parameter of interest, and then generate some visualizations that will help us understand what the sensitivity of that variable has been on the model. So if we select one of those, if we select our workflow representing that, this is what it looks like on DAFNI. So as you can see, we have a starting step, which is our Monte Carlo simulation. And in this case, if we scroll down ever so slightly, we can see we want to run a Monte Carlo analysis. We're going to run this Monte Carlo 100 times, and we're going to vary the target population variable of our model. If we scroll back up to our model, we can see that we are going to run the housing model. And these are the configuration parameters that model takes. And these have been drawn straight from the model definition file I mentioned earlier. So as you can see, the workflow engine and the model definitions are working together here to help you configure what it is you want to run. Now this is all pre-configured. This is a pre-existing workflow that we've written earlier. So all of these parameters are preset, having done it before, and so we are just going to use all of those defaults for now. So having run our model, we then want to perform our sensitivity analysis. That's going to aggregate all of the results together from those 100 runs. It's going to perform our sensitivity analysis, and we can take the results of that and we can run them in. We can turn them into a series of visualizations. So if we select that, we can see that we have configured this to execute as a Jupyter notebook. And I'll come back to that when we talk about visualizations in a little more detail in a moment or two. As I say, the key thing here is that this is a pre-existing workflow. This is something someone has written previously, but it's something I want to use again. So I can just do so. As you can see, there is the ability to modify this slightly. We can add steps if we wanted to. Ultimately, you'll be able to delete them as well, but that functionality is not there yet. But it provides that reusability for people who want to work with this. The image you see there is driven by the workflow definition language, which again is something that within DAFNI we are looking to turn into a national standard for infrastructure workflow modeling. We've used it here to generate that image dynamically, but again, for those of you who want to work more technically, they can be written manually, but they can also be generated programmatically as well. So having written our workflow that we want to execute, we can then do so via the interface here. When we hit the execute button, what happens is it validates our workflow against the definition language to ensure that all of the parameters we've set, the logic of the steps we've specified and so on are all valid and sensible, so that we have the maximum possible opportunity of this workflow completing successfully. And in this case, it's a relatively simple workflow, but you could imagine these workflows being very complex, potentially taking days or weeks to run, and it's therefore good to have a degree of confidence before you submit it that it's going to work as you would expect it to. So if we hit the execute button now, this will now submit. So if we OK that's just some basic information, and that's our workflow in progress. If we go back to the main workflow page, and we scroll down slightly, we can see the top row here is our workflow running. It was submitted at 10:23 this morning, yes. If we select that, we can get some basic information about the progress of that workflow. We can see each of our steps in that workflow down the left, and we can see that they are all pending execution. What we'd see if things were working is the number of those steps that are currently running or that have completed. As you can see, the number of pending components is just updated at the end there. But that's the basic overview. If we look in a little bit more detail by selecting the actual workflow itself, what we see is, or what we should see, is that again we see our workflow defined. And we would normally see the progress of each of these steps. So the steps that have been submitted would have an icon on, the steps that are waiting have a different icon, the steps that have completed would have a different icon again to show whether they've succeeded or failed. This is clearly running slightly slowly, and we're not seeing that. This updates in real time as well. So this is clearly sitting on a server waiting to do something. I'm not going to sit and wait for it to finish. Typically, this workflow takes about 8 minutes to execute, this 100 iteration Monte Carlo. of the housing model would normally complete in about 8 minutes. And that's, that we're not going to wait for that to happen here. Typically, before this process was put onto DAFNI, we were looking at a 4-hour window to complete this particular process that we're looking at. So if we head back to workflows, it's still running. But if we look at something historical, just as a bit of a Blue Peter, here's one I made earlier. This ran recently, and as we can see, each of our steps is completed. We've done our 100 iterations. We've aggregated our data together, and what we can do now is visualize. So if we hit the visualization option, it tells me a little bit about what that visualization is going to do. In this case, we're going to open a Jupyter Notebook. That's great. That's what we asked it to do. If we hit the Visualize button, we're now talking to the visualization suite. What that's done in the background is to spin up a Jupyter Notebook for us, completely dynamically. And what we can do, we'll ignore all the code in here at the moment, but what this has done is it's created us a Jupyter Notebook. That Jupyter Notebook is automatically connected into all of the data we've generated through that Monte Carlo workflow, including all the aggregated data. And we can select a data set from that we're interested in and visualize that up on the screen here. Okay. So that is a very, very brief tour of the modeling service. It shows how you can bring together models, workflow, data in repeatable, reproducible ways to facilitate research, decision, and policy making. So far, as Sam said, this is a bit of a work in progress. So thus far, we have focused on getting the frameworks in place and providing the essential functionality to run these kind of workflows. Over the coming weeks, we're going to start looking at a bit of housekeeping. We're going to look at the ability to add new models, add new workflows, add new versions of existing models, and perhaps deprecate and remove models and workflows that we no longer want to be available to the community. We also very briefly saw what's going on with the visualization suite. We saw a Jupyter Notebook there. In the future, we are hoping to bring in other tools as well. Our Studio would be a good example of that, or perhaps the Zeppelin framework as well. There'll also be the ability to run specific model visualization environments that you're going to see through some of the pilot demonstrations this afternoon. But over the course of the morning, as Sam and Jim have said, it's all about engagement. So if you have other ideas about what you would like to see visualized, the sorts of tools you would like to see in that visualization suite, VR, AR, new 3D rendering, and so on, the panel session and the coffee breaks are a good opportunity to start those conversations with us. Okay, thank you.
So we jump back to the slides very briefly. I personally think the work within the modelling service is probably one of the most kind of exciting. It's got the most potential, I think, to really deliver long-term value. Although kind of improving from 4 hours down to 8 minutes isn't necessarily life-changing, although I'd personally rather recover 3.5 hours of my life, as we start to go on to bigger workflows that take days to run, we're then talking about condensing something down from taking a month or 6 months down to a day. And that really starts to kind of demonstrate what the potential value is that this can deliver. And I think you've then got to think as well, you can potentially provide these workflows to decision makers, and they can actually interact with it without necessarily having to understand the complexities of the code. Yes, you have to be considerate of the fact that we have to be careful what does that mean. But with good metadata, it means we can make sure that that is conveyed in a well kind of concise manner and effectively understood. Ultimately, I don't think any of us would be here today if we didn't think there was an opportunity for change within the sector. And DAFNI is all about, in my mind, supporting that opportunity for change. We're not there to try and say things are done incorrectly now or everything is correct. We're there to support the community as it continues to evolve. And that's why we keep referring to this as a foundation. If we understood everything and the landscape that all the next 5 years was going to look like, we'd be able to sit behind our desks in a very traditional software engineering manner and just get on with it and deliver. But in my mind, that's not going to be effective for this community, and we want the platform to grow in line with the needs of the community. And that's kind of what the last point is really making there. DAFNI can succeed, but only through the cooperation of the community. And that's something we want to echo throughout the lifetime of DAFNI, and whatever permutations it may become in the future. This has to be community owned for it to be successful. And we all have a responsibility, in my mind, of making that happen. Thank you.